Right. So we are going to talk about the reflex arc for this portion. Now, the reflex arc is quite a simple mechanism, and yet a lot of people don't really understand how it works and how significant it is when you are testing something. The reflex arc is very useful because in a single test, you are actually checking the patency or the function of several structures in one instant. And so we have to go through this when we are going to tackle on cranial nerve testing and other neurologic testing as well. So let's dive in. Basically, when you say reflex, you have this basic definition. Now take note of these key words. It is an involuntary, unplanned sequence or action and nearly instantaneous movement. Okay, so in a reflex, you have stimuli and you have a response. Okay, now your response may not always be muscle movement. There might you could have glandular secretion or whatever else, but remember this, you will always have a stimuli, you will always have a response, and your brain is not involved in it. You don't think about it first and then issue a response. It is purely involuntary and near instantaneous. Okay, so why is it instantaneous? Most of it is basically survival. Okay, you don't have time to think about it. Okay, now that we've tackled the basic definition of a reflex, let's go to your um, reflex arc. Take, for example, your deep tendon reflex, or more appropriately, muscle stretch reflex. Okay? Now, let's take, for example, your patellar tendon reflex. So somebody taps on your patellar tendon, and what happens? Without any intervention or thinking in your part, your knee jerks. That's why it's called the knee jerk reflex. And we say of some particular emotional reactions as knee jerk reflexes because they are involuntary and unthinkingly issued. Okay, so let's break it down. First, you have your reflex hammer hitting your, okay, so this is your quads muscle, this is your patella, and this is your patellar tendon. Okay, so you hit the patellar tendon. Basically, you have a receptor. When you hit this, you stretch your quads. Now, in your quads, you have a receptor there, which we will look at closely in a while. So basically, you have a receptor, and from that, you have a sensory fiber. Basically, the impulses of your receptor will travel through the sensory or afferent fiber and into your spinal cord. Which part of the gray matter? Correct. Posterior. Now, from the posterior, let's use blue this time, there's an interneuron, or your posterior immediately synapses with your anterior horn cell. Now, that is already your motor, anterior horn cell. Your sensory here is your dorsal root ganglion, DRG. Now, so you have your anterior horn cell activated, and now it has its motor or efferent sensory fiber, and it goes here to your quads, and it basically makes the entire quadriceps muscle contract at once. So you have a single jerk. Why is it that this reflex does not perpetuate itself? Because you might say, well, once you have a stretch, you have a receptor getting stimulated, and then you have your motor response. And then it will go through, or it will basically have a vicious cycle effect. That is a good question. The thing there is, you also have another receptor here in your tendons. And that is what we call, the receptor is what we call your Golgi tendon organ. Your Golgi tendon organ basically detects your stretch once your quads contracts in your knee jerk, and your Golgi tendon organ, being a sensory inhibitory mechanism, basically stops this reflex after one go. So a good reflex would just give you a limited response, and that's a normal reflex. So let's go back. Let's just erase this one. Okay, so let's go back to the four basic components. You have your receptor. Okay, when you tap it, you stretch the quads. Your receptor detects the stretch, and then you have your sensory nerve. Okay, that's number 2, and your dorsal root ganglion, your sensory neuron. That's number 2. And number 3, it's synapses with your anterior horn cell, your motor neuron, and your motor fiber. Okay, that's your efferent limb. And then lastly, you have your effector organ, which in this case is muscle, your quads. Okay, so you have 1, 2, 3, 4. Okay, so basically that's your reflex arc. Let's break it down one more time. So let's draw the muscle here. Okay, that's your tendon there. This is your muscle belly. Okay, now if you go to your guyton in your muscle physiology, your muscle is actually 2 types. You have your extrafusal, and that's your basic muscle fiber. Most of it is extrafusal. That's your typical muscle, striated muscle fiber. Now you also have your intrafusal fibers. Basically, what it looks like a tiny, well, bag or spindle. That's why it's called your muscle spindle. Your muscle spindle, if you're a physical therapist, a muscle spindle is very, very important when you're dealing with muscle activity. Because your muscle spindle, well, it has your nuclear bag, your nuclear chain. Those are basically receptors. And they detect muscle stretch or tension. Once you stretch the muscle, these intrafusal fibers, these muscle spindles, are activated. Okay? So, basically, when we say receptors, we're talking about this. Okay? So, this is your receptor. Okay? Now, being receptors, impulses from your receptors travel through a sensory nerve fiber. So this is your afferent limb. And now we go to your spinal cord. So your sensory limb here, this is your dorsal root ganglion. Okay, enters the posterior horn and basically synapses with another neuron. And this is your anterior horn cell. This is basically your motor neuron. And for the purpose of later discussion, this basically constitutes or is one of the major part of your motor unit. And basically this is your lower motor neuron. Okay? So I'm just mentioning these words because these are going to be interconnected when we talk about upper motor neuron and lower motor neuron later on, just to whet your appetite. Now, so it synapses with your motor neuron, and your motor neuron, again, it has a fiber. Basically, this is your effector limb or your motor limb, and this fiber basically innervates your quadriceps. So, you have your reflex hammer. So you hit this, you tap the tendon, you stretch the muscle, you activate your receptor. So the impulses travel through your sensory limb, dorsal root ganglion, anterior horn cell, motor nerve, and it ends up activating or making your muscle, whatever muscle there is, to contract. So that's your reflex arc. Now, why is it important when it comes to neurologic testing? Because of one simple act of tapping your tendon, once you elicit a reflex arc, once your reflex arc is normal, okay, basically you are saying there, oh, you have a normal knee-jerk reflex. It means your muscle spindle, your receptor is intact. Your sensory fiber and your sensory neuron is intact. Your motor neuron is intact. Your motor fiber is intact. And your muscle, your effector organ, is intact. So a single tap will tell you how many? 1, 2, 3, 4, 5. At least 4 or 5 or more structures being intact. Now remember, if you do not elicit a reflex arc, and provided that you did the test properly and yet you could not elicit a reflex arc, then what would it tell you? It means either your receptor is damaged, your sensory nerve is damaged, your dorsal root ganglion may be damaged, your anterior horn cell could be the one that is damaged, your motor nerve could be cut, or your muscle could already be atrophied, or your muscle fibers are all shot. So it is a very simple test, and it will tell you a lot of things. Now let's go to another example, since we will soon go into cranial nerve testing and later on other neurologic testing. Now look at this. Your corneal reflex is basically you are touching the cornea with a little wisp of cotton. That's your stimuli. This is your stimuli. Okay? And what is the usual reflex? If something touches the cornea of your eye, what do? You immediately blink. Okay? So your response is you blink. Okay? So let's break it down. So let's make a really cartoony. Okay, so that's your wisp of cotton. So you have your cornea there, and you are basically stimulating the touch receptors in your cornea. So that's your sensory. Your receptor are your touch receptors or your pressure receptors or your pain receptors in your cornea. Okay? And what cranial nerve is that? Remember, in our last lecture, that is basically your ophthalmic division of your cranial nerve 5. Your trigeminal, remember? So, your receptor is observed, impulses coming from your corneal receptors travel through your ophthalmic division of your cranial nerve 5. So it goes to your cranial nerve 5, and then it sends its synapses with what? What closes your eyelid? Remember, in our last lecture, I said, picture a hook that closes your eyelid, and that is your cranial nerve 7, your facial. So, you have your facial nerve, cranial nerve number 7 nuclei, it synapses with that, and this is your facial nerve, and it synapses with the muscles of your eyelid and closes your eyelid. So, with a very simple corneal reflex where you just touch a wisp of cotton into your cornea, what are you testing? Once you have a blink, you are basically affirming or confirming that your receptor is intact. Your cranial nerve 5 nerve is intact. Your cranial nerve 5 ophthalmic division nuclei is intact. Your cranial nerve 7 facial nerve nuclei is intact. Your facial nerve facial nerve is intact. And your muscle governing eyelid closure is intact. Okay? So many structures tested by one single touch. That is why your Reflex Arc is a very, very useful tool. And it is important for you to understand how it works. Now that we know, we can now start with our testing, which will be in the subsequent videos. So thank you for listening.